Good morning, dear students. Welcome to this class on prestressed concrete, Unit 2, uh, and second half of Unit 2 we are talking about. We have discussed in the last session regarding the analysis of prestress when a prestressed member is subjected to both dead load and live load. So these are the mathematical expressions that are to be used finally to get the stresses at top and bottom fibers. So this is the stress at top fiber. To calculate, you need the value of direct stress, it is P by A, and bending stress PE by Z due to pre-stress mg by zt from dead load, mq by zt from live load. So this is stress at top. Hence you can see it is t zt. Okay, right. This is the expression for stress at bottommost fiber. So p by a plus pe by zb minus mg by zb minus mq by zb. Okay, so we have discussed in detail why this is being used as plus, why this is minus. Okay, right. So due to dead load and live load, uh, bottom fibers will be under tension, so this is negative sign, and due to pre-stress the bottom fibers will be under compression, that's why it is plus, and direct stress is positive everywhere. Okay, so this is how the final expressions, and we will see now in this session how to use these expressions in an example problem. So this is the example taken from one of the JNTUK external examination questions, and you see that the question number 3 is the question from you know, this unit 2. So you have to practice all these example problems, and even from the prescribed textbook and also from the old papers of the previous papers of the JNTUK. Right. Let us just read the question first. A rectangular concrete beam having 100 wide, 250 deep, spanning 80 meters, 80, is pre-stressed by a straight cable carrying an effective pre-stressing force of 250 kilonewton. So the tendon is having a force of 250 kilonewton located at an eccentricity of 40 Okay, so it needs to be understood that the tendon is below the CG line of the concrete at a distance of 40 Okay, though it is not told that whether it is above or below, and always we will understand that the tendon is located below CG line, because you know the advantage of having the tendon below the CG line of the concrete. Okay, so the beam supports a live load of 1.2 kilonewton per meter. This is a live load quantity. And question A that you have to attempt, calculate the resultant stress distribution for the central cross section of the beam. At the center of the beam, the density of concrete is 24 kilonewton per meter square. Though it is there is no mentioning of density of concrete, and you shall be able to calculate the dead load from this quantity of gamma of concrete. Okay, so you always need to remember this value of gamma for future use, right? 24 is the density of concrete, value 24 kilonewton per meter square. Okay. So question A is to calculate the resultant stress distribution at central section of the beam. So it is 80 meters span. So at 40 meters section, you take the section of the beam, and at that section, what are the stresses at top and bottom, and draw the diagram. Okay. So this is what is required. Question B, find the magnitude of pre-stressing force, that means P value, with an eccentricity of same value 40, which can balance the stress due to dead and live loads at bottom fiber of the central section of the beam. So the bottom stress from tendon shall balance the stress from dead and live load. That is what uh, is required, which means the bottom stress, total bottom stress shall be zero. Okay, right? I mean, F inferior shall be zero. Balancing means what? The pre-stressing force, stress from pre-stressing force shall be equal to this one. Okay, this total stress from dead and live loads. That means this is equal to 0. Okay, right. So let us solve this one. Parallelly, solve along with me. Take a notebook that you have ready with your notebook. What is you have started preparing your notes. Use the same notes. Okay, right. Let us see the given data is 100 wide, so it is to be 100 Okay, 100 wide, 250 deep, 80 meters, and 250 kilonewton, and eccentricity 40 live load is 1.2 kilonewton per meter, pre-stressing force 250 kilonewton, and we know the expressions. So write those expressions that are to be utilized: stress at top, stress at bottom. Okay, so write these expressions and write the given data. Right. Okay, now you can see, first we will calculate P by A. We need each quantity, whatever is to be used in this equation. So you need P by A value, you need PE by ZT value, you need mg by ZT value, you need mq by ZT value. Okay. So right, first calculating P by A. So P is given as 250 kilonewton pre-stressing force. Convert that into newtons, and then cross sectional area is 100 by 250 is the size of the cross section, and same throughout the length of 80 meters is 100, and 250 is the cross section. Okay, so 100 into 250 is the cross sectional area. That works out to be 10 megapascal is the direct stress value. Okay. Right, coming to PE by Z value, both ZT is equal to Z bottom because the CG of concrete is at center. If the CG is not at center, then Z value will vary definitely. Okay, right. So Z, both top and bottom same. So I'm using Z as just ZT is equal to ZB is equal to Z. So P into E again. So P converted to newtons, E 40 Z value, I by Y, Z is equal to I by y. For rectangle, I is equal to bh cube by 12, and you know y is equal to h by 2, so it is like 2 by h, okay, divided by h by 2. You have to write h by 2. When it is taken to numerator, it becomes reverse, so 2 by h. So it is like bh square by 6 is the z value. So b h square or d square, whatever notation you use, bd square. So b d square by 6. Okay. So if you work out this value, it comes to 9.6 megapascal Newton per mm square. So this is due to pre-stressing tendon. So we have a direct stress of 10 and a bending stress of 9.6, both at top and bottom. Top tension, bottom compression anyhow. Okay, 9.6. Okay, right. So these are like if you draw the diagrams, stress diagrams. So this is both the top 10, bottom 10, and everywhere it is 10 like rectangle, and 9.6 like this. So it is like 9.6 and 9.6. So top tension, bottom compression, because the pre-stressing tendon is located 40 mm below this CG line. Okay, right. This is stress diagram for pre-stressing force coming from stresses coming from pre-stressing tendon. Right. Coming to dead loads and live loads. So take a dead load value. So bending moment at center, you are talking about central cross section. So bending moment at center because of UDL is WL square by 8. What is W? That means dead load value not given, but you have to calculate it. So just multiply with cross section and the gamma value. Okay, so that will give you the dead load value. Okay, so cross section is 100 mm converted to meters, because it is 24 is in kilonewton per meter square. You can observe here, kilonewton per meter square it is given. Actually density, no, there is a correction here from the question paper. It shall be kilonewton per meter cube. Okay, so kilonewton per meter cube is the correction from the question paper. So 24 kilonewton per meter cube, right? Kilonewton per meter cube. So what will happen if you multiply with meters and meters? B in meters, D in meters. So what will happen? Kilonewton per meter. That is your UDL value. Kilonewton per meter. Okay. Right. So 100 converted to meters, 0.1 divided by 1000. 100 by 1000. 250 by 1000. So 0.25. B into D into gamma. Okay. This is density of concrete, 24, into L square. L is 80. 80 square by 8. W, this is WG, total WG value. B into D into gamma is WG. WL square by 8, that is in kilonewton meter. Okay, these are all what we have used are in kilonewton meters. Okay, because this is W is kilonewton per meter. This is into meter square, 80 meter square. Okay, so will come kilonewton meter finally. That is converted to stress shall be in Newton per mm square. So we have to convert this into Newton mm. So kilonewtons converted to Newtons 10 cube, meters converted to mm 10 cube. So 10 power 6. So this is about numerator value WL square by 8 and unit conversions. Denominator as usual Z value same as the above, BH square by 6. Use same value here. That comes around 460.8 megapascal. Okay, this the calculation for bending stress from dead load. Okay, so this is like the stress diagram. If you want to draw, is like this. Okay, so top compression, bottom tension. This is like this. Okay, bottom tension is the stress values, right? And coming to the live load, it is a just a given value, given load value. So WL square by 8 again because it is at center. So 1.2 and L square is 80 square by 8 into 10 power 6 as usual for converting that to Newton mm, because this is like kilonewton per meter. You see, this is kilonewton per meter into meter square. Okay. Okay. So what happens? This meter and meter goes. It will be finally kilonewton meter. So that is to convert into Newton mm. We need to multiply that with 10 power 6. And denominator as usual Z value BH square by 6. So that will come around 921.6 megapascal. And here also same stress diagram. Live load also, top compression, bottom tension because it is sagging. Okay, right, these are the individual values. Now you substitute into the formula, or else you can directly add it from the diagrams. You see, plus 10, this is plus 10 minus 9.6 plus 460.8 plus 921.6. Okay, all these values from the diagram also you can add, or else you can use the formula. You can see it here, plus 10, top we were talking about, plus 10 minus 9.6 top value plus 460.8 plus 921.6. So stress in concrete at top is 1382.8 megapascal Newton per mm. Bottom, if you see, even from the diagrams, bottom plus 10 plus 9.6 minus 460.8 minus 921.6. That is about bottom. So let us see bottom stress, plus 10 plus 9.6 minus 460.8 minus 921.6. Finally, it is minus 1362.8 Newton per mm square. Okay, this is how it is, right? So if you want to draw a diagram, you can just produce these stresses like this. Okay, so top 1360, lesser ordinate, bottom more of value, more ordinate. So it will be definitely not at the center. It will cross above the center. Okay, so this is you have to write along with the other diagrams. You can even draw it from the diagram, or else you can separately. So top higher value, top stress little higher value, bottom stress little lower value, right? This is top 1382.8 plus 1382.8 megapascal, bottom 1362, a little lower value. That's it, 1362.8 8. So the center of the section is this one. So just below the center, it will cross the central cross section, right? So this is about the final stress diagram. Okay. Individual stress diagrams also you can produce, or else just a value. Okay. So better to add the diagrams for this, right? This is question A to answer. Okay. Total 16 marks question. And coming to question B, the stress at bottom fiber shall be 0, or else the stress from pre-stress, you can see, uh, question is find capital P value which can balance the stress from pre-stress uh, due to stress from dead load and live load. That is the question. So it's very simple to just have a formula for bottom stress and take this pre-stress to one side and this dead load and live load to the other side. That will form the formula for having F0. This is the condition here, and P is now unknown value. Okay, you have to find P value finally. So you know mg by z means stress from dead load, stress from live loads already calculated. Use the same values and just keeping P unknown, remaining all known values. This is the stress at the right hand side, total stress at right hand side. Left hand side, take P common, 1 by A remains and E divided by Z remains. Okay, this is E divided by Z, BH square by 6 goes to numerator. So that is equal to 1382.4. Finally, P value comes to 13,000. 17,632.65 kilonewtons. Okay, looks abnormal because the question will have to be like this is like 8 meters or so. Okay, so that looks abnormal value. I mean, even the stresses also looks, concrete stresses also looks abnormal because stress in concrete 460 megapascal, 920 megapascal is abnormal, so abnormal. Okay, anyhow, because it's just an example question, you have to work out for the given data. Okay, so if it is to be a normal value, you shall be getting when you use 8 meters instead of 80 meters. Okay, right? Okay, so this is how we answered these questions. First question is just to get the stresses for a given pre-stress value. Then the second question is when you want to have bottom stress 0, because you have some bottom stress in the first question. So stress at bottom is, 1362 tension. So to avoid this tension, what will be the pre-stressing force? So to make this tension 0, you can see the value of pre-stressing force. You have to increase enormously. So 250 kilonewton is not at all sufficient. So it has to be like 17,632.65 kilonewtons is the required force to make the total concrete section to be under compression. Okay, so if you want to have the total section under compression, that means bottom stress 0 and remaining all these stresses, compressive stresses, if you want to maintain like this, you need to apply this much of pre-stressing force in the tendon. Okay, if you just apply pre-stressing force of 250 kilonewton, this is the stress value. I mean, the somewhere below the center, the tensile stresses will form like this. So if you want to avoid tensile stresses in the concrete, you have to increase pre-stressing force like this. This is how the question and answering with a simple overlapping of superposing of stresses. You have to find stress, direct stress from pre-stress, bending stress from pre-stressing force, also stress from dead load, stress from live load. Just overlap, I mean superpose all those values. Uh, or even the diagrammatic representation is also good in understanding in a better way. Like this, while we discussed when we explained know, uh, the development of the formulas like this. So likewise, you may even produce such diagrams. Okay, something like this. So likewise, you can have diagrams like this is for direct stress from pre-stress, bending stress from pre-stress, dead load, live load stresses, final stress diagram. So this is how final stress diagram may have three options. I told you that everything may be compression, or it can have compression with bottom zero, or tensile stresses may also develop at bottom. These are the three options. Okay. If the pre-stressing force is very high, you will have this. If the pre-stressing force is just sufficient, you will have this. If the pre-stressing force is not sufficient, you will have this. These are the three options. Okay. So that is how we can analyze a pre-stressing member for what are all different stresses happening. This is only at center section. Remaining sections also, wherever you want, you can have the same similar procedure, right? Thank you. We'll come back with the next example in the next session.